Induction motor. Induction motor. Principle of operation. Principle of operation. When three-phase AC supply given to three-phase induction motor, the stator winding set up a revolving magnetic field. When the three-phase AC supply give to three-phase induction motor, the stator winding set up a revolving magnetic field in which rotate at speed 1/20 F by P, where F is frequency, frequency of supply, and P is the number of poles on the winding. The stator winding set up a revolving magnetic field in which rotate at speed. This rotates at a speed is known as synchronous speed of the motor. Is known as the synchronous speed of the motor या induction motor. The revolving magnetic field produced by stator winding interlink with rotor winding and induce EMF in it. By induction. Hence, the rotor winding induced EMF in it cause current to flow in the winding. Due to the rotor winding has a closed circuit due to rotor winding has a closed circuit, so that the induced EMF is produced in rotor winding, causes current to flow in the वाइंडिंग, जिससे इस रोटर वाइंडिंग में करंट फ्लो होता है. द रोटर करंट ड्यू टू वाइंडिंग इंटरेक्ट विथ रिवॉल्विंग मैग्नेटिक वाइंडिंग. द रोटर करंट इंटरेक्ट with the revolving magnetic winding. The rotor current interact winding field thereby tend to turn the rotor in the same direction. The rotor current interact with the revolving magnetic field and thereby tend to turn the rotor in same direction. Same direction. The speed of rotor is always less than synchronous speed. The speed of rotor is always less than the synchronous speed. Synchronous speed produced by stator winding. When three-phase supply throw in stator winding and revolving magnetic field created, so that the speed of rotor is always less than the synchronous speed. The speed of rotor is always less than synchronous speed. The speed of rotor is always less than the synchronous speed. The difference between synchronous speed, the difference between synchronous speed and actual speed is known as the slip. The difference between synchronous speed and actual speed is difference between known as slip, and is expressed as percentage of the synchronous speed. When three-phase supply throw in three-phase induction motor, the stator winding set up a revolving magnetic field in which rotate at a speed of 120 F by P, where F is the frequency of three-phase supply and P is the number of pole on the stator winding. This speed created by stator winding is known as synchronous speed of motor. The revolving magnetic field interlink with the rotor winding. The rotor winding has a closed circuit, so that induced EMF in it by induction. Induced EMF in it causes current to flow in the winding. The rotor current interact with the revolving magnetic field. The rotor current interact with revolving magnetic field and thereby tend to turn the rotor in same direction. The speed of rotor is always less than synchronous speed. The difference between synchronous speed and the actual speed is known as slip and is expressed as percentage of the synchronous speed. Synchronous speed slip in percentage is equal to synchronous speed minus actual speed upon में synchronous speed into 100 into 100. From this formula, slip in percentage is derived or determined. Slip in percentage, a normal induction motor vary from 1 to 2%. Slip in percentage, a normal induction motor varies from 1 to 2%. 1 to 2%. Slip in percentage. In normal motor and on no load. No load. But in full load, about 4% will be slip ring in percentage. About 4% on full load. On no load, 1 to 2%, and full load about 4%. This is the principle of slip in percentage. What is the slip in percentage? What is synchronous speed of the motor? In this lecture, I know why does synchronous speed of the motor and in which phenomena, what is the slip in percentage? synchronous speed minus actual speed upon में synchronous speed into 100. Thank you.